Alright, thank you. Alright, listen. Write these numbers down, and then write them in scientific notation. You don't have to write 1 times 10 to the power up. Just write 10 to the power up, whatever they are. Topic is pH. This is, I think, is the best way to explain it.
I don't remember how to do that. It's like 1 times 10 to the nothing for the first one.
It's like
This
10
one,
to the power.
Because this is basically 1/10, right? So it's 10 to the minus 1. Right.
Oh, never mind.
And you don't have to write times 1.
Well, that's what I did.
What's this number here? 10 to the minus 3.
Did you
Right?
fill out the worksheet from yesterday?
No. What's this number here?
Wait. 1,
10 to minus
3,
1.
4, 5, 6, 7, 8, 9.
You're right, Sarah. 10 to the minus 9. And what's the last one?
5.
5. And you notice by the 4th one, you're just telling me the exponent, right? Because everything else is the same. And when you have numbers that vary like this, this number is like 100 million times smaller than this number, right? So when they vary by such a wide range, all that matters is the exponent at that point. We hardly even care if it was 2 times 10 to the minus 5 or 1 times 10 to the minus 5. The point is just the order of magnitude. It's 10 to the minus 5, 10 to the minus 10, something like that. So pH...
May I have your attention? Mr. Orlandini's trip has been canceled for today. Thank you.
So pH basically works like this, where when you see pH, all it is the exponent for that thing, whatever that thing is. And what is that thing, right? The thing that pH tells you, pH is basically a measure of hydrogen ion concentration. And so remember I used to use M for molarity. Today I'm going to use the brackets. So this would be concentration of H+. That's what that is. So if, for example, I told you that the H+ concentration was 0.1 molar, right? And we can rewrite this as 10 to the minus 1 molar. Right? Then the pH would be 1. It would just be the exponent. And we even throw out the negative because we don't really care about the negative. And if H+ concentration was 10 to the minus 5 molar, what would the pH be? 5. That's it, right? So it's that easy. Now, if it's not exactly this, if it's like 2 times 10 to the minus 5, then we got to do a little bit of math because we don't know, what the exact pH should be. It's really somewhere around 5, right? So here's the question: what is the mathematical operation that takes you from 10 to the minus 1 to give you 1? That tells you what the exponent is. Huh? No? Anybody know? So if I did something to 10 to the minus 5 and got 5, what would that thing be that I did to it? And that thing is called a log. Right?
A what?
Log.
No.
I'm done.
I never even.
That's okay, you'll learn it now. So log just says, when you take the log of a number, it just tells you what the exponent is. That's what a log is. And that's all you gotta know.
We basically just use the exponent in the first line.
Yeah. So when I say what's the log of 10 to the minus 5, well, it's minus 5, right? The negative stays with it. So it's just what's the exponent. That's what logs do. They reverse the exponent. They just give you the exponent and throw away the 10 to the power of 5.
So we,
You do a better explanation than my math.
Thank you.
we keep,
I don't like that.
keep negative and positive, or?
Yeah, we're going to keep the negative for now. We'll talk about the negative in a second. But all I want you to get is just that that's what a log is. It's just the opposite of an exponent, so it undoes the exponent part. So here's the equation you're going to use. So write this part down. pH equals negative, so we can make the negative go away from the exponent. We're going to put a negative out in front. Negative log of whatever the concentration of hydrogen ions is. That means the molarity. If I say it's 0.002 molar, you do negative log of 0.002 molar. The great thing about log is we're not doing it on paper. You just plug it into a calculator. So this is really going to be very simple. So that's it.
So my calculator has log on it?
That'll have log on it, yep. Now, like I said, if it's not exactly a 1 here, then you're going to get something that's not a whole number for the pH. So if I said that the H plus concentration was, let's say, 5 times 10 to the minus 3, right? It's going to be somewhere around 3, but it's not going to be exactly 3. So then you plug in your calculator negative log of 5 times 10 to the minus 3. And you can do it with whole numbers too. If I just said that the concentration's 50, you just do negative log of 50. It doesn't matter how I write the number. And what's that come out to? 2.5 or something.
Negative log. 5 times 10 to that 2.30.
2.30? Okay, 2.3. So it's always going to be somewhere around this, but if there's a number in front, it'll change it a little bit. You don't even have to type negative if you don't want to, right? You can just wait till you get your answer and change the sign. Most of the time, pH is going to be positive. The only time it's negative is if you have a really, really high concentration, right? And looking at these, right? Lower exponent means higher concentration, right? Because 5 is 10 to the minus 5. That's a lot less. That's 0.00001. 10 to the minus 1 is 0.1, right? So lower number means higher concentration.
Wait, so the answer for that one is -5?
Yeah, it's 5. I'm sorry.
Oh.
Because you got to do the negative, right? The pH is 5.
So why do you have to wait for a pH to come through?
Because if there's either too high or too low, that'll eat up some of the other stuff you're putting in there, the chemicals, and then you'll be wasting those. All right, one more little detail, right? So when I give you the problems today, what I'm going to say is you have an acid with a certain concentration, and you don't even have to write this down, but you can if you want. So I will give you like concentration of hydrochloric acid. Let's say I say that's 0.1 molar. Well, this is the same. Once I put this in water, if it's a strong acid, this is going to be the same as hydrogen ion concentration, right? Because all these are going to break down into hydrogen and chloride. So whatever I give you for the concentration of the strong acid, that's the same as H plus concentration. So don't be confused by that. So basically all you got to do today is take the concentration I give you for the acid, do negative log of that number, figure out what the pH is. All right? Here's my worksheets. All right, JJ, you gotta turn that off.
Can you say my name right?
I think you turned that off. Is it really?